Hello viewers, Wagadaruna taking you through the story of A-Level Applied Mathematics. And this video, we are going to go through the Matigo Examination Board mock paper for Senior 6 Math Paper 2. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So we shall begin with section A. Section A, question 1 says that time x in seconds for phone calls made by 11 customers at a public telephone booth were recorded as follows. Find Roman 1, the mean value of x for the given data and the interquartile range for the given data. So this is ungrouped data. So for mean, it means first add all the values. When you add all these, you'll come up with 1166. Then therefore, to get the mean, you get that summation divided by the total number of items. Remember, there were 11 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's why you divide by 11 to come up with 106 as the mean value of x. So that was Roman 1. Now we shall go to Roman 2. Roman 2, that wanted us to get the interquartile range for the given data. So when it comes to interquartile range, we arrange in ascending order. Then after that, we look for the median. So 1 with this, this with this, this with this, this with this, this with this. So this becomes our median. Therefore, we shall come and circle it and call it the median. But remember, they want the interquartile range. So we need to get the lower quartile and the upper quartile. So lower quartile is the midpoint of the first half. Then upper quartile is the midpoint of the second half. So in this case, from here to here, what is the midpoint? This goes with this, this goes with this, therefore this will be the lower quartile. So shall come and put it there. Then for this, we shall again get the midpoint, which is this. Therefore low upper quartile is that. Therefore now that I've got the upper quartile and lower quartile, I can subtract the 2 to get the interquartile range. And that's what they wanted. That was question 1. Now we shall go to question 2. Question 2 says, an electric weighing scale is corrupted such that the actual weights of 24 grams and 54 grams are recorded as 35 grams and 60 grams respectively. Using linear interpolation stroke extrapolation, estimate Roman 1 the weight which is recorded accurately, and Roman 2 the weight which the scale records when it is unloaded. So that is interpolation and extrapolation. One, you need to tabulate. We have actual weight and recorded weight. So actual weight, which is 24, is recorded as 35. Then actual weight, which is 54, recorded as 60. Then shall now get the weight which is recorded accurately, means if here there is x, even here there should be x. Now, why did we put extrapolation? Why couldn't we put this here? Okay, so for you to know whether it's interpolation or extrapolation, look at the difference. Here, the difference is, okay, 35 minus 24 is it 11? Yeah, it's 11. 610 minus 54 is 6. Do something? it is converging, it is reducing. It was 11, now the difference has reduced. So at this point, the difference will be 0. Like that. So if you put this value here in between, it means it is not logical, because the difference here can't be 11, then 0, and again 6. No. So that's how you can understand that you are going to use extrapolation. After that, you can now equate the quotients, cross multiply, collect like terms, and get the value of x. And that's what they wanted in Roman 1. Then for Roman 2, they want the weight which the scale records when it is unloaded. When unloaded means the actual weight is 0. So you come here and still do our tabulation. Interpolation, it is advisable that you always tabulate by extracting out the necessary values. So we have used this now. This time it is still extrapolation, but on this side. Hope you remember the first one. Let me show you first. For this Roman 1, it was extrapolation, but on this side. Reason, here it was 11, here it was 6, meaning 0 will be on that side. So I can't put 0 on the other side. But for this second one, I've used extrapolation, but on this side. You know why? Because for this to be 0, you see this, from here to here there is an increase, meaning this side, the actual weights keep on increasing. Therefore, I must put it this side where actual weights keep on reducing until it will be 0. So you always be keen with the position. Then you shall come and equate quotients, simplify, and make y the subject. And that's what they wanted. That was question 2. Now we shall go to question 3. Question 3 says a box of mass 4.5 kilograms is pulled across a rough horizontal plane, okay, by a string inclined. It is the string which is inclined. Some of you, when you saw this word inclined at an angle of 20, you drew immediately an inclined plane. It is not okay. It is the string which was inclined, but the plane was horizontal and rough. Okay, the tension in the string is 32 newtons. The particle's acceleration is 4.2 meters per second squared. Find the coefficient of friction between the particle and the plane. So shall come here and make a sketch of our horizontal plane with the body, then put the forces now, begin with the weight. 4 kilograms, the weight becomes 4.4 kilograms, weight becomes 4.5 g, where g is acceleration due to gravity. Because there is this weight, there will be a normal reaction error. Then they told us there is the tension of this. So this is the tension inclined at an angle of 20 degrees to the horizontal. So from there we need to resolve that force. So we shall get the horizontal component of 32 cos 20 and vertical component of 32 sin 20. It is also rough, but for you to know the direction of friction, you need to know the acceleration. So the particle is moving in that direction of the pulling force. Therefore, friction must oppose motion. So now that we have got the first diagram, next is to resolve. So we shall begin by resolving vertically. Vertically means this plus this are equal to this. So upward forces are equal to downward forces. So we shall come and put upward forces equal to downward forces. Then we make R the subject. Bring this one this side, we'll come up with 4.5g minus 32 sine 20 to give you 33.1554 newtons. But the question wants coefficient of friction, so we are going to now resolve horizontally. So resolving horizontally, it means this is bigger based on this acceleration than this. That's why we say this minus this is equal to MA. So substitute for R, M, and A. You remain with mu as the only unknown. Therefore, mu can be made the subject. And that's what they wanted. Then question 4 says, the table below shows the price relatives of a set of items A, B, C, D, which is this. So these are price relatives, these are their weights. Given that the sum of the weights is 40 and that the weighted average price index is 126.7, calculate the numerical values of X and Y. So first we need the total weight. So all this will be equal to 40. That's what they have told us. They told us that the sum of the weights is 40. So all these ones, when you add them, you should get 40. Therefore, that means I can get an equation in X and Y, which is that, and I'll call it equation 1. So I'll need another equation. The other equation will be got from this, which is weighted average price index. So I'll come here and remember what weighted average price index is. Then I can substitute. So price relative times the weight, and you sum all of them, items A, B, C, D, over the total weight, which is 40, will be equal to the weighted average price index. So next is to simplify. This gives this, this gives this, this gives this, this gives that, and that. Cross multiply, you'll come up with that. Then rearrange to get equation 2. So now we have two equations with two unknowns. Next is to solve simultaneously. So equation 1 multiplied by 30 minus equation 2, you come up with this. Here I wanted to eliminate x. So I'll end up with y being equal to 5. After getting y, I can now get the value of x from equation 1 by substituting for y to get the value of x. And that's what they wanted. Then question 5 says, use trapezium rule with 6 ordinates to estimate this. Correct to 3 significant figures. So the first thing to do is to get the strip width. So the difference between the two over the number of ordinates minus 1. Number of ordinates minus 1 gives you the sub-interval. And in the end, we'll come up with 0.08. Now, you should be keen here. I've used the decimal because it is a perfect decimal. If it was recurring, then it wouldn't be okay. If there were very many decimal places, like 10, it wouldn't be okay. So that I can now tabulate. So write the ordinates, and then, so here it is okay to start with 1. You say call this 1, 2, 3, 4 up to 6. It is still okay. For me, I chose to begin with 0, so that I can know that this means the number of intervals. Then you will go the values of xn. The first starting value is this here. Then keep on adding this like that until you reach the upper limit. Then from there, the values of y are split into two. There's what we call extreme values and intermediate values. Extreme values are these ones, using these ordinates, this and that. using this first and the last. Intermediate are these ones in between. So when you use extreme values, the first one using 0.1, you come up with that. You should be keen of the decimal places. They have told us 3 significant figures, so you count 1, 2, 3. Then you add 2 more. That is called boosting accuracy. Then also the last one, when x is 0.5, you come up with that. Add the 2 to get this. Then I can now go to the intermediate ones. When x is 0.18, I come up with this. When x is 0.26, I come up with that. X is 0.34, I come up with that. X is 0.42, I come up with that. Then you add all those values. After that, I can now come and get the area they wanted. So a half times h in brackets this sum of the extreme values plus twice the sum of the intermediate values. Then you can use a calculator, maintain the approximate sign, and then round off to the required accuracy. So basically that is what they wanted. Now we shall go to question 6. Question 6 says, at noon, okay, ship A is 8 kilometers due east of ship B. Ship A is moving due north at a constant speed of 10 kilometers per hour. Ship B is moving at a constant speed of 6 kilometers per hour on a bearing so that it passes as close as possible to A. So that means the question is under closest approach. Determine, Roman 1, the bearing on which ship B moves. Roman 2, the shortest distance between the two ships. So here I shall need to make a sketch. First, locate the initial positions of A and B. They told us that BA is 8 kilometers due east of B. So if B is here, east of B, you reach A after 8 kilometers. Then from there, they told us ship A is moving due north at 6 kilometers per hour. Due north at 10 kilometers per hour, which is that. So when I reverse it, I'll come up with that. Ship B is moving at a constant speed. Speed means magnitude of velocity. Constant speed of that on a bearing so that it passes. So that is called the course for closest approach. Therefore, I'll come and say that for closest approach, I'll come at B and put there the reversed velocity of A. So you reverse the known velocity. You reverse the known velocity. So this VA is known. So that is what I reverse and put at B. This is VA, but I put it at B of the velocity whose direction is unknown. Then from there, you are going to draw what we call a relative path. Relative path is a line, okay. It is a line showing the direction of the relative velocity. But how do you draw it? It should be between the line joining the initial positions and the velocity and the reversed velocity, the velocity which has been reversed. So in between here, I can put any line and I call it my relative path. So that is now my relative path at an angle which I don't know. Then from there, I'll make sure that I drop a perpendicular from where this ended. So drop a perpendicular to meet the relative path at 90. That's what I mean. So that is the condition for for course of closest approach. Each time they ask for direction of a certain body so that closest approach is achieved, always remember that the velocity whose direction is unknown must be perpendicular to the relative velocity. Then closest approach, shortest distance, you drop a perpendicular from A to the relative path. So by geometry, this angle is equal to this. Do you agree? Let's see how. If this is theta, this will be 90 minus theta. Okay, 90 minus theta. So 90 minus theta, this is also 90. So what will be the balance? Because angles of a triangle add up to 180 degrees. Or if not, you can say this angle and this angle are complementary angles. So in the end, it will be theta. So now I can answer question 1 by getting the value of theta. I can say cos is equal to adjacent over hypotenuse to give you theta as 53.13. But they want the direction in bearing. So I'll come and say it is 053.13 degrees. So bearing is written by 3 digits, which is this. I think this is what I mean by 3 digits before the decimal. Then shortest distance, they want this value of d. I've already got the value of theta, and I know this hypotenuse. So what would this opposite be? It means I'll use sine. So d is equal to ab sine theta, substitute and get the shortest distance. And that's what they wanted. Then question 7. Question 7 says the cumulative mass function of a random variable t is given by that. By leaving the constant a in your answer, okay, Roman 1, determine the probability mass function of t, and Roman 2, the probability of t greater than or equal to 20 but less than or equal to 40. So we shall come, and to convert from capital F(x) to small f, we have to differentiate. So differentiate function by function. First is differentiate this to come up with this. Now this one, this division disturbs students. This is a constant value, so it is no longer you don't use quotient formula. Okay, if you use quotient formula, the answer will come out, but it is not a must that you should use quotient since this is a constant. So here, what you needed to do, make it constant down, then differentiate only the numerator. This differentiate that to get this, differentiate this to get that. Then also you have to differentiate 1. Most students forget the derivative of 1, but it has to be seen. That is where this 0 is coming from. This 0 elsewhere, it comes from this derivative of 1. Then this comes from here. Now if you don't show this one and you just put 0, that will be just cram work. Now for Roman 2, they ask for probability of t from 20 up to 40. The good thing, we already have capital Ft, so what we need is to substitute. So we shall get capital F40 minus capital F20, and that will be the probability they want. So for capital F40, it means we go back to our capital Ft and substitute. Where there is t, you put there 40 to get capital F40. Then for capital F20, it means where there is t, you put there 20. So let's do that. So I'll come and substitute where there is t, I put there 40 to get F40, and where there is T, I put there 20 to get F20. Simplify this in this box bracket, you will come up with 40A minus 1200. Then 40 is common in both, so factorize it out, you will remain with A minus 30. And that's what they wanted. Then question 8 says, a resultant of two forces, this and this, acts on a rigid body at a point with position vector this. Okay, Roman 1, determine the moment about the origin or caused by this resultant force on the rigid body. Then hence state the moment of the couple required to achieve rotational equilibrium of the body. So first you'll need to get the resultant of these two forces by adding the two. So when I add, I'll come up with that. Then from there, I can now get the moment about the origin. Moment about the origin is got by crossing. Cross the position vector with the resultant force. So this is position vector, this is the resultant force. I'm now going to cross. Crossing means when I put I here, I ignore these values and deal with this. Minus, when I put J, it means I ignore these and I deal with these ones only. When I put K, I ignore this and deal with these two. Now from there, magnitude of a matrix 2 by 2 matrix is equal to its determinant. So I'm going to get the determinant, this minus that. Product, so product of this minus product of this. Then this is 1 minus this, which is 5. This is 3 minus this, which is negative 5. So in the end, we'll come up with this as the moment. But they also wanted the moment of the couple. Moment of the couple, you simply get the reverse, which will be this. And that's what they wanted. So that was section A. Now we shall go to section B. Section B, section B contains 8 questions and students are supposed to answer any 5. But since this is a revision, we shall answer all the 8. So question 9 says, the manager of a women clothing shop did a small survey on the amount a woman spends on clothes and her age. The findings were as follows. So woman, age, then expenditure in dollars. Then part A, plot a scatter diagram for the data. Part B, draw a line of best fit on the scatter diagram and use it to estimate Roman 1, the age of a woman who spends $130 monthly on clothes. Roman 2, the monthly expenditure on clothes for a 28-year-old woman. Then part C, calculate the rank correlation coefficient between the monthly expenditure and the age and comment on your result at 5% level of significance. This question is under scatter graphs and correlation, and therefore the first step is to tabulate before you answer any part. So values of x, that is age. Now because they want us to draw a scatter graph and use it to estimate, we shall need to get the summation of these values of x. Why do we get the summation? In to help us get the mean point. Then do the same for the expenditure. So add all these ones to get the total here. So now we are going to rank. Ranking is done in descending order. So you look at the biggest up to the smallest. So the biggest for X is 55, which gets rank 1, followed by 44, which gets rank 2, followed by 38, which gets rank 3, followed by 36, which gets rank 4, followed by 32, which gets rank 5, followed by 30, which gets rank 6, followed by 25, which gets rank 7, followed by 23, which gets rank 8, followed by 21, which gets rank 9, and lastly 16, which gets rank 10. That was ranking for X. Now shall rank also the expenditure. The biggest is 300, which gets rank 1, followed by 280. But now this 280, we have two values with 280. Now in ranking, identical values get a similar rank. And that rank is the average of the would-be position. So would-be means if they were different, one would take position 3, 2, another one would take position 3. But the average, but because they're identical, we shall take the average of 2 and 3, which is 2.5. So this will get 2.5, and this will also get 2.5. Then next will be 250, which will take rank 4. Rank 4 because the third position is already taken here. Next will be 246, takes rank 5. Next is 190, takes rank 6. Next is 180, takes rank 7. Next is 150, takes rank 8. Next is 128, takes rank 9. And lastly 116 takes rank 10. Okay, so next is to use a calculator and subtract carefully. Most of you make errors in subtraction, so subtract carefully. This minus this gives that, this minus this minus this, like that. So when you subtract, you shall come up with those values of D. Then next is to get the values of D squared. So this squared, 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 and that squared. The next is to get the sum of all these values of D squared, and the sum will be 320.5. Okay, so now we can begin to answer the questions. Part A was about plotting a scatter diagram for the given data. So plotting, we shall need a graph paper. Then we draw the axes, horizontal and vertical. Then we use intervals of 2 centimeters and get a suitable scale so that all those values can fit. I think we realize that here the minimum is that and the maximum is 55, so all those values should fit. Then do the same for the vertical, intervals of 2 centimeters, and choose a suitable scale. Then from there, we're going to now plot. 16 corresponds with 280, which gives that. 21 corresponds with 300. 36 corresponds with 180. 44 with 116. 25 with 280. 55 with 128. 23 with 250, 38 with 150, 30 with 246, 32 with 190. Okay, so that is called a scatter diagram. But part B, let's first go to part B. Part B says draw a line of best fit on the scatter diagram and use it to estimate. So let's first draw a line of best fit. Now, line of best fit has conditions. Three conditions to meet. One, it must pass through the mean point. So now that is the reason why we got these summations. So with those summations, we can come and get the mean point, x bar and y bar. Therefore, the mean point is 32, 212. So 32 corresponds to 212. Come and show it on the graph. Then from there, we're going to draw our line of best fit. Condition 1, it must pass through this mean point. Condition 2, it must pass through any other one or more points plotted. And condition 3, it must leave equal or almost equal points on either side. So when you see that line, it has passed through 1, 2, 3 more points after the mean point. 2, how many points have it left on this side? 1, 2, 3, 4. What about this side? 1, 2, 3. So that means it has fulfilled all the 3 conditions. Now that you have drawn the line of best fit, next is to estimate. The first estimation, they want the age of the woman who spends $130 on clothes, and Roman 2, the expenditure on clothes for a 28-year-old woman. So first, when the amount is 130, what is the age? So shall come on the vertical axis and look for 130. Draw a horizontal line to meet the line of best fit. Then where it meets, draw a vertical line to meet the horizontal axis and read off that value. Okay, then also for a 28-year-old woman, so look for 28 on the horizontal axis, draw a vertical line to meet the line of best fit, then draw a horizontal to meet the vertical axis and read off that value. So basically that is what they wanted. So shall come here and put it in writing. But before that, let's first see the marks for the slide. Okay, so now shall come and say that for part B Roman 1, the age of a woman who spends $130 on monthly clothes is 42.25. And Roman 2, the monthly expenditure on clothes for a 28-year-old woman is $244. That was part B. Now we shall go to part C. Part C, it says, calculate the rank correlation coefficient between the monthly expenditure and the age, and then comment on your result at 5% level of significance. So first is to quote the formula for Spearman rank correlation coefficient, substitute n means number of pairs, and get the output. In decimals, output should be in decimals. Then from there you can now comment. Significant at 5%. Why do we say significant? We get the comment from the table. Remember there are 10 pairs and we're interested in Spearman, but we're interested at 5%, which is 0.65. So that table value is what you compare with the calculated value. What we calculated, but remember it is magnitude. You see these 2 bars. The 2 bars mean magnitude. So you are going to compare 0.9424 with 0.65. Of course, the calculated value will be bigger than the table value. Therefore, it will be significant because of this statement. It says significant if this value, magnitude of the value of calculated, exceeds the table value at this percentage. So basically, that is what they wanted in question 9. And now we shall go to question 10. Question 10 says the numbers this, and that are calculated with percentage errors. Note this word, percentage errors, respectively. Determine the errors in X, Y, and Z. So let's begin with that. So percentage error, to get the error, it will be that percentage error, which is 4 over 100 times the value of X, to give you error in X. Which is, so when I multiply, I come up with this as the error in X. Do the same for Y. Percentage error is 3, so it will be 3 over 10 times 13.18 to give you this. Error in Z, percentage is 2, so 2 over 100 times 5.1 to give you this as the error. And that's what they wanted. Then Roman 2 says, determine the limits within which the exact value of the expression this lies correct to 3 decimal places. When they give accuracy in numerical methods, remember to boost accuracy. Just what it means. So lower limit means minimum value. So minimum of this means this should be minimized, and here the numerator should be maximum, denominator should be minimum to get the whole maximum. So come and substitute minimum of this, maximum of this, minimum of that. Simplify to get the output, which is 3 decimal places. Then upper limit also get the maximum. It is like the reverse. So substitute and simplify to get the output to 3 decimal places. And that's what they wanted. Then Roman 3, they want the percentage error in the expression in Roman 2 above. This expression. So percentage error is error, maximum error over working value times 100. So we need to get the working value first. Working value means you don't include any error, just write the values given. So using a calculator, we'll come up with this. We are maintaining decimal places because even the maximum and minimum had 3 decimal places. Therefore, absolute error now will be maximum minus minimum over 2 to get this. After getting absolute error, you can now divide the 2 and multiply by 100 to get the percentage error. And that's what they wanted. So that was question 10. Now we shall go to question 11. It says, a projectile P travels in a vertical plane over a level ground. Its position vector r at time t seconds after projection is given by this. Okay, where distances are in meters and the origin is a point on the level ground. Part A, write down the height from which P is projected. So let's begin with that. Height, it means that when T was 0, what was the height, or what was the value of R? What was the position? So let's start with that. So initially, when t is 0, we shall come up with r being equal to this, then this times 0, this times 0, so all these go to 0 and remain with this. Therefore, the height, remember, this vector means the first column is for horizontal and the second one is for the vertical. So vertical, it is at a height of 5 meters. That was Roman 1. Then Roman 2, they said what? Write down the value of acceleration due to gravity in this case. So for vertical motion, we know that y is equal to ut sine theta minus a half gt over projectile. So by comparison, it means that the coefficient of t squared here is a half g. And in this case, coefficient of t squared is 0.5. But because this 0 is for horizontal and 5 is for the vertical, yet this is vertical motion, we shall deal with only 5. Then we make g the subject, and that will be the value for acceleration due to gravity in this case. That was Roman 2. Then part B says find the displacement of P from t equal to 3 to t equal to 5. So that means that when t is equal to 3, what is the position vector? And when t is equal to 5, what is the position vector? And after that, can you subtract the 2? So when t is equal to 3, position vector is that. When t is equal to 5, position vector is this. Then required displacement is got by subtraction to give you that. Then part C, show that the equation of trajectory is given by this. So from that expression, x, remember r is xy, so x is this upper part here, which is 30t, implying that t is that. And y is this lower part, which is this. So trajectory means you eliminate time. So eliminating t, you come up with that, simplify, and you get what is required. And that's what they wanted. Question 12 says, a bag contains 30 white, 25 blue, and 20 red. 3 balls are drawn one after the other without replacement. If a random variable x is defined as the number of blue balls picked, Roman 1, construct a probability distribution table for x. Roman 2, calculate the expectation of x. So here, there are 3 balls and there are 3 pickings. Drawing a tree diagram will be more hectic. So what I'm going to do, I'm going to use the second method because picking without replacement can be answered in 2 ways. One, you can use tree diagram, or you can use the knowledge of permutation and combination. So come and say that probability for x equal to 0 means no blue ball picked. It will be no blue ball picked means the chances, it means this was the where you picked from. So from this and this we have 50, okay, 30 white and plus 20 red balls gives a total of 50. But from those 50, they picked 3 balls. That is why we're saying here 50 combination 3 over the sample space. Sample space means what is the total available possibilities. There are 30, 25, 20, which is 75, but of the 75 you want 3 balls. That's why you see here 75 combination 3. When you use a calculator, you'll come up with this, but don't write in decimal. Leave it as a fraction. Then x equal to 1, it means 1 blue ball and 2 others. So this 1 ball is picked from the 25 blue, and the 2 balls are picked from the 50 remaining ones over the sample space to give you this. Then for x equal to 2 means 2 blue balls and 1 other. So 2 balls are picked from the 25 blue and 1 is picked from the remaining 50 over the sample space to give you this. X equal to 3 means 3 blue balls. 3 balls are picked from the 25 over the sample space to give you that. So now we can come and draw our probability distribution. Probability distribution means you tabulate when it comes to discrete. So when x is 0, that's the probability. When x is 1, that's the probability. When x is 2, that's the probability. When x is 3, that is the probability. And that's what they wanted. Then Roman 2, they wanted the expectation of x. Expectation means xpx, and sum it up. So this with this, this with this, this with this, which is here, and this with this. So when you add all these ones, you'll come up with 1, and that will be the expectation of x. And that's what they wanted. Then question 13, it says, but derive the Newton-Raphson formula for solving the equation this. Okay. Taking x naught equal to pi over 2, show that x1 is 10 pi over 21. I think let's begin with that. So given this equation, to imply that fx is that, when I differentiate this, I come up with this, this, I come up with this. Then from there, I can quote Newton-Raphson formula and substitute xn, fx, and f prime x. But remember, there is xn, so make sure there is xn everywhere. Then this negative and this, okay. Here, this and this can be factorized out and goes with this to become positive here and also positive here. Hope it is clear, but if it's confusing you, you can just stop here and you deal with that. I only wanted to reduce on the negatives. Then taking x naught to be pi over 2, come and substitute pi over 2 here, then cos pi over 2 minus pi over 2 divided by 20 sine pi over 2 plus 1. Now cos pi over 2 is 0 if you use a calculator. Sine pi over 2 is 1. That's why I see 20 times 1 to give you 1. So simplify. This is here. Then this divided by 21 is pi over 42. Then this subtraction gives you the required expression. And that's what they wanted. Then part B says, show that the iterative formula for finding the 50th root of a real number capital N can be given by this. And hence find 50th root of 50 to 3 decimal places using x naught equal to 2. So yeah, let x be the fifth root of capital N, meaning put power 5 on both sides, you come up with this. Take everything on one side, you come up with that. So when one side is 0, it implies that the other side is the fx. So this is our fx. Differentiate it to come up with that. Then you can quote the Newton-Raphson formula and substitute. It was about the expression required was given, so you have to simplify until you get the given expression. Get LCM to come up with this. Open this bracket, come up with that. Then split the numerator. This goes, this and this remain with the power of 1. This one, the whole of it remains. So they have 5 and 5 here. It can come out. That's why you see 1 over 5 here. And that's what they wanted. Then for the hence part, they wanted the fifth root of 50, meaning capital N is 50 and x0 is 2. Therefore, substitute x1 and come up with that. Use x1 to get x2. Use x2 to get x3. And use x3 to get x4. Now, how do you know that I should stop here? You keep on rounding. They wanted, let me see the question. The question wanted 3 decimal places. So that means that here, after every successive, you compare 3 decimal places. Here it is 2.225 and here it is just 2, so it is not okay. Then here with this and that, here 3 decimal places are 2.225, here it is 2.188, so they are not the same. Then compare again with this. Here it is 2.188, here it is 2.187, so they are not the same. Compare with this, 2.187, 2.187, so that is what they want. Therefore, you stop there and quote the root to the given accuracy. So that was question 13. Now I shall go to question 14. Question 14 says, a particle of mass 2 kilograms is attached to one end of a light inelastic string of natural length 1.2 meters. The other end of the string is attached to a fixed point O on a rough horizontal plane. Okay. The coefficient of friction between P and the plane is 2 over 5. The particle is held at rest at a point B on the plane where OB is 1.5 meters. When P is at B, the tension in the string is 20 newtons. The particle is released from rest. Part A, find the speed of P when OP is 1.2 meters. And part B, the particle comes to rest at point C. Okay, find the distance BC. So here, first of all, we are going to begin by making a sketch. So you come and draw the horizontal ground, then draw a fixed point and the particle which has been stretched. Before stretching, the original length was 1.2. And after stretching, it became 1.5. Therefore, the extension is 1.5 minus 1.2 to get 0.3. Then the tension, they told us the tension is 20. So tension arrows must point each other. Then the acceleration, if released, it will go this side. But since the particle is rough, the plane is rough, so it should oppose motion. Friction must act in a direction so as to oppose motion. So if motion is this side, friction will be the opposite side. So we shall first quote the formula for tension in Hooke's law, which is T is equal to modulus of elasticity times extension over original length. So substitute for tension, extension, original length. You'll come up with modulus of elasticity as 80 newtons. Then from there, for motion BP, for motion from here up to here, we shall use conservation. Conservation of energy means work done against friction is equal to initial total kinetic energy minus final total kinetic energy, because by conservation energy would have been the same, initial and final, but because there is friction, some of the energy is wasted. So you are going to come and say work done against friction is friction times the distance moved. Friction times the distance moved is equal to initial total energy, which is Ke plus elastic potential energy. Ideally, there should be three. There is kinetic energy, potential energy, and elastic potential energy. But potential energy comes into play when it is vertical motion. For this case, it is horizontal motion, meaning initial height and final height are the same. So final kinetic energy is that. Then your mu r is mg. Ke is 0 in this case initially. Elastic potential energy is that. Ke is that. Final at point P, and elastic is 0. Then you can substitute. Before substitute, let's mark for this slide. Okay, so I think we're aware that in math we don't mark a formula, we mark a substitution. That is why you don't see any mark here. We shall wait for a substitution. So when I substitute, I'll come up with that. The good thing, V is the only unknown, so make V the subject, and that will be the velocity with which it passes point P. Then Roman 2, they wanted Roman 2, the particle comes to rest at the point C. Okay, find the distance BC. So that when it comes to rest, velocity is 0. So work done against friction is equal to work done against friction is initial minus final. So this is friction, which is mu mg times distance moved to a point where velocity is 0. That's why you see here final Ke is 0. Now here, this you'll ask yourself, why aren't we adding elastic potential energy? Because initially here, let me first show you. Initially here, we added elastic potential energy. But in this case, we are not adding elastic potential energy. Why? It is because beyond point P, the string is no longer tight. And because it is no longer tight, it means there is no more tension. Because there is no more tension, it means there is no energy stored in the string. Because an energy stored, if you look at this, energy is stored when there is an extension. Okay, so at this point, energy stored will be 0 because x is 0. So beyond that, there will be no more energy stored in the string. Therefore, there will be no elastic potential energy. So elastic potential energy is available when there is an extension in terms of strings or a compression in terms of springs. So that is why we are only dealing with kinetic energy. So substitute mu mg m, v, and this is 0. So here I can make s the subject, and that will be the distance they want. So distance BC will now be BP plus PC. And that is what they wanted. Then question 15. The Ugandan Traffic Service is doing a clamp down on speeding. During a recent speeding trap, they collected the following data. Okay. Part A. Calculate the values of A, B, C, and D. I think we shall begin with that. What you should know, you can either do it vertical, or because we have two totals, we have these totals and these totals. So for horizontal, it means this plus this is this, this plus this is this, and this plus this is that. For vertical, it means this plus this is this, this plus this is that, and this plus this is that. So whatever I do is okay. So when I use that knowledge, I can come and get the values of A. So value of A is that, value of B is that, value of C is that, and value of D is that. That was part A. Now we can go to part B. Part B, they said, determine the probability that a driver selected at random is a male driver and speeding. That is intersection. So we shall come and look for male, and speeding, which is that, over the sample space, which is 1,000. Therefore, probability of M intersection S will be that. Then Roman 2, probability that a driver selected at random is a female driver given that she is not speeding. That is a condition. So we shall first get the intersection. Intersection of female and not speeding is C, which you got. And probability of not speeding will be this over the total. So we shall come and say that the intersection is that, and the probability of not speeding is that. I think we saw it, meaning that now I can get the conditional probability. Therefore, the probability of female given not speeding will be got by intersection over S complement, which is that. Now, part B. Part B says, so now we shall go to part C. Part C says, are the events of being a male and speeding independent? Show all relevant working to support your answer. So remember, for independent events, the intersection of the events is equal to the product of their individual probabilities. So you'll come here and look at probability of male and probability of speeding, then also compare it with the probability of male and speeding. So probability of being male is that, probability of speeding is this. Then when I multiply the two, what will I get? This is what I'll get. But remember, we saw that previously here, we saw the probability of male and speeding is 398 over 1000, meaning these two are not equal with this, and because they are not equal, it implies that they are not independent. So basically, that's what they wanted in this question. Then we shall go to question 16. Question 16 says, in the figure it should be up below. In the figure below, EF is a portion of the curve this EF is given by this equation, and BCDE is a rectangle. This is a rectangle in which BC is 3 centimeters and CD is 5 centimeters. Part A, show by integration that the x-coordinate of the centroid of the portion ABEF is 9. So let's begin with that. So first is to remember the formula for the x-coordinate by taking moments about the y-axis. We shall come up with x-coordinate for the center of the centroid will be this over that. So this is got from the formula that moment of sum is equal to sum of moment. But more of this is available on this platform. Check under application of integration under calculus. So let's integrate xy with respect to x. Substitute for y or expand, then you can integrate. So integrate this, I get this, integrate this, you get this, then substitute the limits and get the output. Then area, this is area, so it's given by that, integrate, substitute limits and get the output. So now that I have this and this, next is to divide and get what they wanted. That was part A. Part B says find the distance of the center of mass of the whole lamina ABCDEF from the y-axis. So they want x-coordinate. Because they ask for center of mass, shall let rho be equal to mass per unit area. We're using area because the given figure is a lamina. So let's first tabulate something for his identification of how to take moments. So for figure ABEF, the weight we saw, let's get where it's coming from. Remember, rho is weight per unit area, so my aim is to get the area. Area is 2/3. So when I multiply it by weight, by rho, it means I'll be getting weight. So that weight is got by area times rho. Then the distance from y-axis, we already saw it, x-coordinate was 9. Then figure BCDE is a rectangle, so weight is area times rho to give you that. And the distance from the y-axis will be 2 because let's see where it's coming from. So this is the y-axis. So if this is the center of gravity, the center is at these lines of symmetry. So from here to here is 2 units. Then from here to here is a half of this. Remember, this is 3 centimeters. So divide by 2 to get 3/2. That is why you saw we wrote 2 plus 3/2. So that's where this came from. Now you shall go to the whole lamina, you add the area, these ways to get the total weight. Then distance is what you are going to look for. So I'll come and take moments about the y-axis. Y-axis means you multiply this with this plus this with this is equal to this with this, which is this line. Simplify, rho is common throughout, so I can cancel it out. Then I can now make x bar the subject, and that is what they wanted. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be on U.A.C.E Math 1 UNEB for the year 2023. So we have taken long because we prefer to upload marking guides when report on work of candidates have been released. So the reports were released, so now we can upload the videos and also take you through the analysis of the report so that you can avoid the same mistakes which made others not get a better mark than they thought to get.